Welcome back to eCoreAcademy, everyone. My name is Anita, and I am one of the teachers here along with my brother, and we're also co-founders. As you can see, we're going to have a new Algebra 2 lesson today, and we're just going to be continuing along with normal distributions, which is the lesson we started in the last video. We're just going to end this series with a part 2, and in this video, we'll be focusing on 2 more examples in addition to that introduction so you understood what normal distribution was in the last video, along with the example on female brown bear weights. So you're going to see 2 more real life scenarios just like that in this video. And this video is going to be solely dedicated to those 2 because they're going to expand on what we learned in the last video. So like I said, we're looking at 2 more examples. The first one's going to involve a meal survey, and then the second one is going to involve final exam scores from a university lecture class. So before I dive into the video, I do want to go over 2 things. First, you'll see this bell curve here, and hopefully it's familiar to you. This is actually an image I got off of the internet, and here you can see that the mean, hopefully you know that since this is a normal bell curve with standard deviation. So first of all, let's go over normal distribution, just a quick review. So normal distribution kind of shows you how data values vary randomly from the mean in a sample. In addition, when you have normal distributions are usually what happen in nature, like we saw in the last video with the female brown bear weights. Usually you're going to see more frequent data values around the mean, which is the average, and the average is what usually occurs the most. So that's why the average is usually the middle and the peak, because that's what usually occurs the most. That has the highest frequency of data values. But then when you start going towards the right or left, you're moving towards extremes. You're moving towards either a lower weight in the case of the female brown bears or a higher weight in the case of the female brown bears. Since you see extremes more rarely in nature, that's why the frequency of those data values starts to decrease as you move towards one or the other spectrum of the bell curve. And in addition, when you have a normal distribution, it is symmetrical, meaning the mean is the middle or the line of symmetry, and you can see that the bell curve to the right and then to the left of this line of symmetry are identical. So if I fold it in half, they would be identical to each other. So that's just a bit about normal distributions, a review from the last video. You also hopefully remember the empirical rule, which stated that 68% of the data values are going to all fall within one standard deviation of the mean. As you can see here, one standard deviation of the mean means one standard deviation above, which is this 34%, and one below. So you can see this 34%. And when we add these two, we get that 68% we were talking about in the last video, which is one whole standard deviation. If we look at 2 standard deviations from the mean, we're talking about 95% of the data values falling into those 2 standard deviations, which is also true here. We have the 68% here, so you include the first standard deviation, and then we see this 13.5 and this 13.5. Well, if we add these together, we're going to get 27, and 68 plus 27 is equal to 95. So these all account for that 95% falling in 2 standard deviations. So this range right here would be 13.5 and 13.5, because we would split, so it's 95 minus the 68 in the middle is equal to 27, and 27 divided by 2 is 13.5, and the second 13.5 over here. Next you have 97.5% of the data falling in 3 standard deviations. So if we add 2.35 and 2.35 together, we're going to get 4.7, and 4.7 plus the 95% we already have here is equal to that 99.7. I'm sorry. I'm forgetting the empirical rule. Just make sure you memorize those numbers. And then when you get to that value, you have like a remaining 0.5%, because 0.15 times plus 0.15 is equal to 0.3. And that 0.3 plus the 99.7 will give you 100% of the data values. So that's just how you look at a bell curve. And this is really important. Not only do you have to remember that 68, 95, 99.7 rule, but also remember that these percentages right here, because these are those percentages halved. For example, these will represent the ranges of the standard deviations below and above the mean. So make sure you understand that. So that being said, before we dive into the video, I'd really appreciate it if you all could like, subscribe, hit the post notification bell, and drop a comment down below. All of those would be really appreciated. Also, check out all of our social media. Okay. So let's jump into example number 2, because we already covered example number 1 in the last video with the brown bears. In example number 2, we're going to look at some meal surveys, and I'll show you what I mean. Here's the problem. I took it directly out of the textbook because they did a good job explaining it. So this is a meal survey. So in a survey, the responses to the question, how much time do you spend at meals in 1 week? I think there's a typo. Were normally distributed. The mean or mu, as you same as x bar, pronounced mu. That's a symbol you also see in biology, but in this case, mu stands for mean. Was 13 hours. The standard deviation was 3 hours. So the question was, which was being asked to the sample population, was how much time do you spend at meals in 1 week? And then after the responses were collected, whoever is analyzing the data determined that this was a normal distribution, meaning the curve we saw in the last photo is what applies here as well. We're also told the mean was 13 hours, standard deviation was 3 hours. So what that means is we're going to draw a line plot like here. 13 is going to go in the middle because it's the mean. Then we're going to try to find the standard deviation. So we're going to add 3 to get one standard deviation above 16, and then subtract 3 to get 10, a standard deviation below, one standard deviation below. Then we'll add 3 to 16 again to get the second standard deviation, which is 19. We'll subtract 3 from 10 to get 7, which is a second standard deviation below the mean, and then subtract 3 again to get 4, and then add 3 to 19 to get 22, again to find the third standard deviation. And we literally just copy those percentages because those percentages from the last photo apply to every single normal distribution. We're told here that this is normally distributed, so we can apply those here. Therefore, I wrote 34, 34, 13.5, 13.5, 2.35, and 2.35, and then that 0.15 is hanging out here. And then I just drew these lines to show that 68% of the data values fall within one standard deviation, 95 in two standard deviations, and 99.7 in three standard deviations. With that being said, after we make that graph to help ourselves out, let's actually start solving the problems that we're going to be asked. The first one is, what values are one standard deviation from the mean? So one standard deviation is going to be one above and one below. So we're going to have our mean, we're going to add 3 to it and subtract 3 from it to find one standard deviation. If we subtract 3 from 3 from 13, we get 10. If we add 3 to 13, we get 16. So 10 to 16 is one standard deviation, so 10 to 16 hours would be the answer to this question. We're going to see part 2 now of example number 2 meal surveys. B. What percent of the responses would you expect to find from 10 hours to 16 hours? Well, we already determined that 13 is our mean, 10 is one standard deviation below that, and 16 is one standard deviation above that. So what does that mean? Now we're asked how many responses would we expect to find from 10 to 16 hours? Well, let's look at the percentages we have right now. 10 to 13 is 34 hours. As we remember from that very first image I showed you on the introduction slide, those percentages, again, they apply to every normal distribution. Just memorize them. So 10 to 13, one standard deviation below is 34%, and 13 to 16, one standard deviation above the mean is 34%. So 34 plus 34, you'll see, is 68%. Also, if you know that 10 to 16 is one standard deviation, then you also know that from the empirical rule, 68% of data values will fall within one standard deviation of the mean. So you don't even have to add the 34 and 34 if you already know that since this is one standard deviation, it's automatically 68% of the data. So let's look at C now. Suppose that there were 100 responses to the survey question. As you can see in the problem, they never tell us how many people answered the survey. They just tell us that this was normally distributed. They also tell us the mean was 13 and the deviation was 3. So now let's assume that there were 100 responses to the survey question of how many hours it takes in 1 week for people to eat meals. So how many responses would you expect to be values from 10 hours to 16 hours? Well, what we found in the last problem was a percent. We found out that 34 plus 34, or 68, is a percent of one standard deviation of the mean. That means that 68% of the data values of the total set are going to fall in that 10 to 16 range, or one standard deviation of the mean. Now we're actually given a value of how many total responses there are. Well, what we can do is we can take that 100 total responses and multiply it times 68%, which as a decimal is 0.68. If we multiply that and we get the answer 68 responses, what this means is that 68 out of those 100 people probably fell in that one standard deviation. Because we took the percent we found, we multiplied it times the total, and we found out what part of that total falls in one standard deviation. So that would be 68 responses. Now let's look at D. Of 100 responses, how many would you expect to be values from 16 to 19 hours? So this is almost like combining what we did in B and C those last two problems together. First, let's look at the range 16 to 19. Think of it as intervals or ranges. So I find that right here. It's 2 standard deviations above the mean, 16 to 19. We see that this is 13.5. And remember, these are the memorized values you just have to have. As we see, this is 13.5 from our graph. This means that 13.5% of the data values are going to fall between 16 and 19. However, that doesn't answer the question because we're asked of 100 responses. We're not asked for a percent. Therefore, since we determined this 13.5%, we'll convert this to a decimal, which is 0.135, and multiply that times the whole, which is 100, and we'll get 13.5. So this means that 13.5 responses out of 100 indicate that it takes 16 to 19 hours to eat. However, you can't have a non-integer value for a response. You can't have 13 and a half responses. Do you know what I'm saying? You can have 13 responses, but you can't have half a person respond to something, if that makes sense. Therefore, we can just say 13 to 14 responses because this is saying, this is more of an approximation. This is about. If your teacher was asking you to round it, you always, just to be safe when it comes to integer values like this, we're talking about responses, people, things that have to be whole, you can be safe and round down to 13 responses. Okay, so now let's talk about the next example, which is about a lecture class. So a lecture class is usually what you see in college. It's those large classrooms. It's almost like round, like stadium seats, if you want to think of it that way. Well, that's what I've seen so far in movies and colleges I've seen. But it's a really large class where a teacher is giving a lecture. So here's the problem. In a university lecture class, there's a total of 174 students. So we're given the total. Unlike the last problem where we were just supposed to assume there were 100 responses to answer the question, in this we're actually told that there are 174 students. Now we're told that the final exam scores have a mean of 68.5. And a standard deviation of 7.3. So the mean, we're told, is 68.5. That's why you see the number line here, and 68.5 is right in the middle because it's the mean, and a standard deviation of 7.3. The grades on the exams are all whole numbers, and the grade pattern follows a normal curve. So when we're asked questions that are going to follow, they're going to be referring to whole number grades, because usually in class we do get whole number grades. We don't get like point something, we get whole number grades. So using those whole number grades, what we're going to do is approximate. So the standard deviation, as you can see here, is actually in percents, but we're going to round these as compared to the questions we're going to get, because the grades were whole numbers, but the standard deviation and mean are not. So first, let's put this graph together. So we have 68.5 is the middle, the mean. We're told that the standard deviation is 7.3. Well, I can add 7.3 to get 75.8, one standard deviation above the mean. Add 7.3 again to get 83.1, which is two standard deviations above the mean. And then add 7.3 one last time to get 90.4, which is three standard deviations above the mean. Then I can go backward and work and see what's below the mean. So 68.5 minus that 7.3 is going to give me 61.2, which is one standard deviation below the mean. Subtract 7.3 again, you get 53.9, which is two standard deviations below the mean. And then you just get a third standard deviation below the mean. We'll get 46.6 by subtracting 7.3 from 53.9. And then you'll see that outlier 0.5 and 0.5 on both ends of the spectrum for the few individuals who fall into those categories. And then again, you see these are the percentages you're going to have to memorize. This is one standard deviation, so 34 plus 34 is 68%. And then this is two standard deviations, 34 plus 34 plus 13.5 plus 13.5 is 95%. And then these are three standard deviations, 2.35 plus 2.35 plus that 95% is going to give us 99.7. And then we have 0.15, and 0.15 hanging out outside. So with that being said, let's move into the first problem. Find the number of students who receive grades from 1 to 2 standard deviations above the mean. So 1 to 2 standard deviations above the mean. So we're not focusing on what's on the left side. So that will narrow down any confusion. We're not focusing on the left side because that is below the mean. We're focusing above the mean. That's why I actually underlined this multiple times. So focusing above the mean. So now we're told 1 to 2 standard deviations. Well, what is one standard deviation above the mean? Well, that's 75.8. Two standard deviations above the mean is 83.1. So we're looking at this range 75.8 to 83.1 only. So we're just focusing on this. So that's why I wrote 75.8 to 83.1. Well, what's the percent of data values falling in this range? It's 13.5%. So 13.5% of the students got in the range of 75.8 to 83.1. Therefore, we have that percent, 13.5%. We're going to turn it to a decimal, 0.135, and multiply it by the number of students, the total, so that we can get an exact number of students. If we multiply it times 174, we get 23.49. But because we have students, we have to talk whole numbers. Therefore, we can approximate it to 23 to 24 students because that decimal falls between the integers 23 and 24. Again, if you're asked to round, just be safe. And if your teacher asks you to round, just be safe and round it down to 23. Look at the next example. So same concept with the lecture class. Now we're going to find the number of students who receive grades of 61 or below. Keep in mind that 61 is usually failing, and 61 here is shown as an integer because we're told that the grades themselves are actually whole numbers, although our mean and standard deviation might not be. So we're going to look at our graph and we're going to find the interval or the number that indicates a range of the standard deviation that's closest to 61, and I see 61.2, which is very close. So we're approximating here. So we're at 61.2. We're trying to find the number of students who receive grades of 61 or below. So we're looking at 61.2 and below. So that means we're looking to the left. If we go towards the right, we're looking at grades above 61, which we don't want. We want grades 61 and below. So we're going to look to the left of that. And what we do is we're just going to look to the left, and we have these three intervals right here representing this left half. So what we're going to do is we're going to actually add these percentages together, 0.15, 2.35, and 13.5, because all these percentages represent the grades below 61. This interval represents grades from about 50 to 60. This interval represents grades from about 45 to 55, and etc. And then you just keep going down all the way until maybe someone got a 0 on this. So you're going to add those 3% together, and you're going to get 16%. Then you're trying to find the number of students. You're not trying to give a percent as your final answer. So you're going to convert 16% to a decimal, which is 0.16. Multiply that times the total, which is 174, and then you're going to get 27.84. But again, since we're talking about students, you got to round that to a whole number. So you can say 27 to 28 students approximately got 61 or below on this test. So the next problem. Suppose there are 140 students in the class. So let's scratch that number 174 students that was given in the problem originally. Now we have 140 students in the class in this scenario. About how many would receive grades from 69 to 75? Well, let's first find the interval on here. So we have 61.2, that's too far from 69. We have 68.5, which is only 0.5 away from 69. So we'll look at that. We'll focus on that. Then we get 75.8, which is very close to 75. So we're pretty much looking in this range here because we were asked from 69 to 75. So just this interval here. Well, we're going to find the percent of students falling in this interval, and we know that's 34% because that's a memorized percent. Now we're going to convert that to a decimal, 0.34, because we are not asked for the percent, we're asked for the amount of students. So we're going to take 0.34, multiply that times the total, which is 140, and then we're going to get about 47 to 48 students. So that's pretty straightforward as well. Next, of 140 students, so we're still working with that 140 students, how many would receive scores between 54 and 75? So we're trying to find which range we're working in. Well, let's find which value down here on this number line is closest to 54. 46.6 is too far, but 53.9 is 0.1 away from 54. So this is a really good approximation. Then if I keep going right, I find 75.8, which is very close to 75. So we're looking at this range right here. We're looking 2 standard deviations below the mean to 1 standard deviation above the mean. So we're going to look at all these percentages that fall in these categories. We have 13.5, 34, and 34. So we're going to add all of those together. If we do, we're pretty much going to get 68 plus 13.5, which is going to equal 81.5%. But we're asked again for the amount of students. We're not asked for the percent. So we're going to convert 81.5% to decimal value. So that's going to be 0.816. Multiply that times the total, 140. We're going to get 114.1, but because they're students, we're going to round it. So 114 to 115 students. So whenever you get a decimal value, like for this case, 114 plus 1, find the integer to the very left of it on the number line and find the integer to the very right of it. In this case, this number falls right between 114 and 115. So that's just how I would write my answer. But again, if your teacher asks you to round, always safe to round down to 114. And I think this is the last one that has to do with this problem. What would you have to score to be in the top 16% of the class? Well, let's just understand first what these data values represent. These data values represent what percent of the class falls in a given range. For example, if I looked at the range 68.5 to 75.8, we know that 34% of the kids fall in this range. However, now it's almost like we're reversing the question. We're given the percent, we're told 16%, but we're trying to find what range are we talking about. Well, if we look at the right, these are going to be extremes. Left is also extremes. However, left is failing extremes. That means we're dipping all the way below like 45%, which is not good. If we go towards the right, however, our scores are getting higher and we're getting closer and closer to a perfect 100%. So the top of the class means the best scorers or the best students in the class. So we're going to focus more on the right side of this normal distribution. If we do so, we're trying to find the top 16%. Well, we're considering 90.4 as 3 standard deviations above the mean, meaning only 15% of 0.5%, 0.15% of students in this class actually got between maybe a 90 to 100. So that's a very small percent. Because of that, what we're going to do is we are just going to take 0.15 into consideration. Then we're going to move left 1 standard deviation. Now we have 2.35%. We're going to add that to the 0.15%. And we're going to get 2.5%. Well, that's still not up to 16% because we're looking at the top 16%, not the top 2.5%. So we can jump left one more time. We get 13.5%. 13.5% plus 2.5% is 16%. So right here is the top 16% of the class. We're not going to focus on anything below 75.8. So we're not going to focus on anything below 1 standard deviation above the mean. That being said, if we add 13.5 plus 2.35 plus 0.15, we will get the top 16% of the class, meaning the lowest score that someone who's in the top 16% would have gotten was a 75.8, because if we go to the left of that, we are going above 16%. The top 16%. We're looking more at 16 plus 34, which is 50% of the class. We are focusing just on the top 16%. That's why the lowest score someone could have gotten was a 75.8. So you would have had to score greater than a 75.8 to be on this right half of the top 16%. If we round that, the lowest score would have been 76%, because remember, we were told whole number scores. So we round that up to 76%. So in order to be in the top 16%, you need to score above a 76%. And that's all I have for you today. I hope you enjoyed the video, and if you did, please like, subscribe, hit the post notification bell, and drop a comment down below. Also, check out our socials, and you can check out our website and Gmail while you're at it. Thank you for watching, and I'll see you in the next Algebra 2 video. Bye!